Hello friends, in this video let's look into a problem from Leet code. This is a problem, very interesting problem. It's called spiral matrix. It says, given a m cross n matrix, return all elements of the matrix in a spiral order. And then there are some examples. Spiral order is 1 2 3 like this. No So you start from the top, move left to right, then after getting to the right edge you move down and down till the bottom, and then no you move right to left, and then you move from bottom to top. Now from this left bottom corner you move up, and then you kind of do again left to right until you reach the middle element. So this is about 3 cross 3 square matrix, and these are the elements which are provided as input, and output is the traversal, in the spiral manner as we just described. So 1 2 3 3 6 9 8 7 4 5. Now this could be done for a rectangular matrix as well. So here there is a 4 cross 3 matrix, and again you use the same sequence. You'll do left to right, then after you reach the top right corner you do top to bottom, and then right to left, and then you move up and you traverse through all possible elements, and once you have reached all unvisited elements you do again left to right, so you end up here at the 7. So this is again the traversal 1 2 3 4 8 12 11 10 9 5 6 7. So let's try to write a program to return this traversal, and as you have seen here in the template, it needs to return list of integers and functions called spiral order. It takes as a parameter matrix 2 cross 2 matrix. So let's start. How can we do this traversal? Looks complicated, but if you think there is not no many complications, we can start approaching this problem and see how we can handle it. So first thing is, we have m. M is the size of the matrix, number of rows. So let's initialize this, because this we will use in our application. So to uh, determine the looping condition. So let's just start by putting up some variable matrix dot length, and and so here yeah, it's coming from this constraint. So m is matrix dot length and n is number of columns, which is matrix 0 dot length. And some of the points missing is we don't know what is the maximum possible values for m. So here it says n should be less than 10, but doesn't. Okay, m and n should be between 1 to 10. It is good information. I can instead use a byte here, and just to save memory. Then matrix inputs, whatever is the matrix values, they will be between -100 to 100. That's also interesting problem. So that's also interesting no information in this. So for this, you don't need actually integer. It could be just a byte here. So yeah, you don't need to return a list of integer, but whatever is, if the problem says that, then we use it like that. Okay, so just for consistency, I can kind of keep it like int. So this is your m cross n. So now we have to find the length of the array, or the list which we would like to return. So let's say we take integer, and this is our final traversal which we will be returning, and we say int m cross n. So either you can create an array first and then at the end convert it to list or return it, or other possibility would be I just create a list, and list could be, I can say, array list. So, and we can provide the size, so that it's always good to provide a size, and we say list, and there's an integer list, and this called result. So that's all, and now would like to traverse. So the approach I would like to take is, so we keep track of a few boundaries to solve this problem. First thing is we can keep track of this place, this is left, and you can keep track of this boundary which is your top, and this one again you can keep track of bottom, and this is left, and then this is right. So the traversal, we have to start the direction which is left to right. So and we have these boundaries which is left, right, and as we move on, we kind of uh, change these boundaries, uh, and that way we can kind of traverse, and we also keep changing the direction after we reach every end, every boundary. So that's how our traversal could be. And to do this, let's now start by so now let's start creating variables to track these values. So now let's say we have top, and we initialize it to 0. Let's do initialization as well. Then we have bottom we can initialize with m minus 1, and then we have int left is again 0, and then we have int right could be no n minus 1. So this is our values, initial values of top, bottom, left, right. But as you see, as we complete this traversal, our top moves down. So yeah, here we have to traverse till 5, and so on. So in a bigger matrix, it will be completely over the boundaries, and then it will come to the center. So now we have initialized these variables which we want to use, and we can also specify a direction, and direction we can say int direction, and then let's say I was always you know prefer using enums to store such things, but yeah, for simplicity in this problem, let's use it as an integer. Let's have a direction, and direction can have various values. We can specify 0 is for left to right, and 1 is for, say, top to bottom, and then we have 2 which is for right to left, and then we have 3 which is bottom to top. So we have these 4 directions of traversals which we need to do now, and we need to keep on doing this multiple number of times until you have top is less than equal to bottom, and left is now less than equal to right. This is our condition to determine how many times we have to do the iteration uh, into various directions. Now we have to set direction. So directions by default set to left to right. This is good because yeah, that's how it starts. And so yeah, we can do a check here. So we have yeah, this is the end of the while loop, and then we have a check here. Say if direction is equal to 0, which is for left to right. I will make it more clear here. For left to right, what we do, we traverse the array left to right, and yeah, here this is brackets and move here. So we I equal to 0. We start from left. So yeah, we say left, and we traverse till right, whereas I is less than or equal to right. Yeah, it's very simple because now how would you traverse from left to right? You will traverse start your index from left, and then you move till right, and then you have plus plus. No, you move to next element every time, and then you have result, and you add the result, which is your matrix, and you add this portion, 1 2 3. So our row is constant, which is the topmost row first, and then I is about your column, which we will be traversing. So this is our traversal, and once we complete this traversal, we need to, as we have visited all elements of the top, we will increment the top. So right now it's 0, so it will become 1 in after the traversal. This is about traversing the if there is the left to right direction. Now next thing is direction. If it is 1, then what to do? We have almost the same condition here. Okay, okay. So I will copy. So here, if 1, we have the direction of 1 is top to bottom, and then if direction is 2 and 3, let's now update them also here in one go. So when it is 2, 2 means bottom to top, and then the last one is you have okay, so bottom, top to bottom. Sorry, here this one is the last one. So you traverse top to bottom at the end, and then the third iteration is your left to right, top to bottom, and then right to left. So here it will be right to left. Okay. Now nothing simple. We just have to replace this. Here we have top to bottom. So when we do the traversal top to bottom, we will increment I from top to bottom. Okay. Left to right we have done already. Then when you do right to left, you just have to say right and say left. Okay, and then last one is bottom to top. So bottom and then top. Okay. Now we have got these looping, start and end condition already set. Okay, see, now when you traverse from right, right is always greater than left. So here, no, minus minus, because right is n minus 1. In this case, it will be 2. Left is 0. So you have to decrement. Same when you move from bottom to top, you will decrement the index. And now, we'll add the elements to the result. So here, what you do is we have when you traverse from left to right, your top is constant. You go through the all the elements in the top row. When you traverse top to bottom, your right no column is the constant, which will be equal to right. So here I will say, yeah, sorry, here right, and when you iterate I no, from top to back. Now, when you iterate right to left, you have row which is bottom, which is constant, and then your column is moving no, from the higher index to lower index. Then when you move from bottom to top, your left is constant, and you iterate the other way around. So left column is constant. So here we iterate. Uh, Sorry, yeah, we have some typos. So these were no, the way we were kind of traversing or equating over the elements of the array. And once we traverse left to right, we incremented top. When you traverse top to bottom, you have incremented, you have to decrement your right, because you have covered every element of the right. When you move right to left, you have covered everything in the bottom. So you will be decrementing the value of the bottom. And when you move bottom to top, you increment left. You are moving towards the right. So these are various conditions which you do. Now, now this is how it will be dir. So we can use here else if, because so that you don't evaluate all these situations again and again. Yeah, because dir will have one of the values, so we don't want to, once you have found that okay, I know direction is 0 or 1 or whatever. I know we need not have to iterate. We need not have to check the conditions for other equalities. And then once you have done one iteration, you change the direction. And the way to change the direction is simply you add 1 to the direction. So if you are, left to right, you just add 1, you'll come to top to bottom. Then you add again 1, you come right to left. Then you come, no, you again add 1, you go bottom to top. Then you want to cycle it back, right? So the way we can do is either we reset it after three. If it's 3, then you check whether direction is 3 and then reset it to 1, or simply you can use modular operator and you say dir plus 1. So it once it goes past all, it comes back again. So this is how to set the direction. Now, once this loop is executed completely, yeah, so here we will have the loop which will execute completely, and then we need to, we have added all the results in the list. So simply one thing which we have to do is return this list, which is called result, and that's all. This will complete your function, which is spiral order. And let's see, let's try testing this. Let me run the code and see, no, is there any compilation error? Okay, there are. There is index out of bounds for len 3. Okay, let me see if there is any typo. Yeah, I see a typo. Top is less than bottom, and left, yeah, this looks good. Okay, so dir left and till right, and bottom is higher, I is greater than top. So this one and then white again is higher value. So yeah, these are some directions. The right has to be greater than left. We iterate until right is greater than left, and when bottom is also greater. Yeah, so I from bottom to top, and we have to check I should always be greater than top. So this will fix this problem, I believe. Let's see. Sure, yeah, we saw that. Okay, this is printing as expected for 3 cross 3 matrix. Let's test this for the other rectangular matrix. Let me put this, run the code, and let's see what happens. Yeah, this is also printing as expected. The output, this one and this output is matching. Let me test one more case, which is we say just if we have one element, what would be the result? I think this is invalid, but yeah, 1 cross 1, I believe. Let's see. Okay, sorry, this one I missed a comma. We need a comma here. So I run again. So yeah, this is also expected result. And if I just put a square matrix with one element, now this should be invalid. Again, the test case is invalid. I guess yeah, one is not a valid value of this. So yeah, looks good for the time being. Yeah, so I think I can test this one better. So you see, okay. So again, I missed the comma. Okay, can't. So lead code doesn't allow me to run too many test cases very quickly, and we say like this: 2 cross 2, 3, 4, just to make sure everything is perfect. Because you see this was very simple problem, looks complicated initially, but if you do it systematically it could be done in a very graceful manner. Now I'll submit this to see if it passes all the tests. Wow, I see accepted, solution is accepted. Hope you enjoyed this. In case of any questions or any suggestions about this solution, feel free to write in the comment section of this video. Thank you.